Alright, here we go. We have CIS-125 whiteboard review, and today is 9/19/16. We did our first problem, went through the steps, so I just made this up, landing spots. So we're making spots or circles for landing, let's say helicopter, balloons or something, and we're going to actually have an area in here, this green area, that we want to paint, white or whatever color. I told the students then that this area across, I had it right there, 5 foot. Told them 1 gallon of paint, 10 square feet. Here I said we're going to paint the area white that I have marked green. And then I asked them, what's the first most important thing you have to do to understand the problem? What do we want out? Well, I really only want out, in this problem, how many gallons of paint it's going to take to paint that area. So that was the first step. So we went and visited a little bit, talked about it, and made sure the students understood the problem. Then we'd already talked a little bit about the output, how many gallons of paint. That's what we went out. Then we talked about what we would have to put in before we talked about the process. And the student said, well, you got to know the radius of the outside circle. So I gave him some test data. I said, well, okay, what if it's 30 feet? And we talked about constants we had. We knew it was a 5-foot band, so band equals 5. We knew pi, 3.1416. We need that in our calculations. And we know 1 gallon gets us 10 square feet. So a gallon per square feet is 10. So we have some values of constants that we have, and then we went in and figured out the calculations. Area of the entire circle, we said, would be pi r squared. And we're using the word radius here for the radius. And the area of the small circle is pi r squared, but the radius of the small circle would be our current radius minus how big that band is. In this case, it's 5, right? But instead of putting 5 in there, we put the word band. And that's going to be important later on. And then that's squared raised to a power. Now, a little bit about math, right? If you have parentheses, it'll do this first, and then what does it do between an exponent and multiplication? Exponents next, then multiplication. So if there were no grouping symbols, it does exponents, multiplication, division, adding, subtracting. Alright, next thing we figured is the band area. How much area do we have to paint? In the area of the entire circle minus the area of a small circle. How many gallons of paint do we need? You can take that area divided by how many gallons per square feet. So in this case it's 10 in this particular situation. Okay, and that'll give us how many gallons of paint we need. So this whole process here, we refer to it as IPO. You've got to have an IPO designed before you move on to the actual design of your program. It's really important. Input, process, output. You got to be able to figure this out by hand, or at least lay out the plan before you can think about having some technology do it. So all of this fits what we would call the analysis stage. Define the problem, figured out the IPO. So here it is in a nutshell, so to speak. First thing, you understand the problem. typically the second thing, what do you want out? Usually, then what do you have to put in? You know, what information do you have that's to put in? For example, the given. We're given that, or we're going to put that in. Then the actual process. How do you get from here to here? Get it? How do you go from some input so that you can calculate the correct output? It's analysis. Alright, once we had the analysis done, all that's analysis, right? Next thing we go to now is the design. So the first thing we're going to do in the design is we're going to create a legend. We're going to figure out these variables, what we're going to use to represent many of the items over here. Again, the variables, these, in this case, are all numeric. But they could be string variables. And then numeric, we're going to talk about either integer or floating. So we're going to use the radius to represent the radius of the circle. We're going to use band to represent bandwidth of the area to paint. In our case, it's 5. But we're going to call it band. Pi is going to be pi, the value pi. Gallons per square foot. Number of gallons required to cover a specific one. That is 10 in this case. Area, entire circle. Find the area of the entire circle. Area of the inside circle. That will be the area of the inside circle. Band area, that's the area we want to paint. We already figured out the calculations over here. And then gallons of paint, how much paint we actually need. So we have a legend, so we know what variables we're going to use to represent what in our program. And these are actually going to represent locations in memory. It's good to remember, they're going to represent locations in memory. So here's the big picture again. We got the radius, the band, pi, square feet, and then we'll be able to calculate all of these from these processes. But these then are the variables that we define them. They're going to represent, variables. You might think of that will represent some location in, if I do a computer, we got the processor, and then we have memory. And information from memory is going to go up, get processed, and back. Go up, get processed, and back. Then we took that information and we created then a flowchart. Initialization box. We initialize those constants in here, assign the variables. Now these variable names we're using over here, boy, they better match exactly what we put in the legend. Arrows should be connecting the boxes. Input box. Right, I have an action word, input, please enter radius. I got that in quotes. So that'd be just a string. It would just print that information out. And then here's the variable. Then over here, then we move over here. The arrows touching boxes flow to the right and down, primarily. Action word. Got action words here in all these. Later on we'll talk about leaving that one out, that action word. And then here's the formula. Okay, calculate on the right, store to the left. Calculate on the right, store to the left. Calculate on the right, store on the left. Calculate on the right, store on the left. And then down here we can get an action word, print. We're going to print gallons required, and then this is the variable location. This last, is going to store it there, and we're going to print it out there. Then here we have the stop, start, the flow of our program down to the right. So what's left to talk about? When you write the pseudocode for that, you can pretty much write the commands, all action words, and make sure you got a nice straight line as you're writing those out. Okay, so some words we have the start, some words we'll have a stop, and all of those lines in between. I don't know how many there were. Then you can take some test data and do a walkthrough. Walkthroughs are pretty simple on a sequential, sequence or linear process. You just go from one step to another, and you keep track here of your variables. But we didn't get quite this far, but we'll talk about the pseudocode. Talk about the pseudocode and the walkthrough on Wednesday. Add that to our work. And once we get this done, then we're able to take this and go ahead and look at writing some code. That's it.